Bank. Sorry, it's the recording. With the Korea Import-Export Bank, KXM. And I would like to thank them for co-organizing this with ADB. And I would like to also thank all our participants who are very enthusiastic and have provided very interesting insight into smart and digital solutions that Korea has for challenges facing urban areas. And today we're going to be talking about energy management and smart solutions for energy management. And in our lineup, we were going to start first with the Jeju Special Governance Province with Ms. Mi Young Kim, who was called into an important meeting and she couldn't make it. So it's a last minute meeting. So she will be here in 30 minutes, I am told. So as a solution, we are going to be presenting the solutions first. So I am going to just present the title of the presentation with the name of the person and their title. Their full bios are in the brochure that we circulated. So this is because I'm cognizant of time. Every presenter will have 15 minutes to speak, and we will have a Q&A session afterwards. So for the first presentation, I would like to present Mr. Hyung Ying Kim, who is Senior Researcher, New Energy Business Planning Department in Hyundai Electric and Energy Systems Company. And he will be talking about distributed energy system using renewable energy and energy storage management, system management. So we will start with him. Mr. Kim, please take it away. And I will be sending you a reminder for the time because we're very cognizant of the other presenters' time as well. So I know 15 minutes probably very, very difficult, but I'm counting on you. Thank you very much. Go ahead, please.
So everyone hear me and everyone can see my presentation slide. Yeah, I think it is. So thank you for giving us a really great opportunity to introducing our solution and our company. And I'm really happy to be here today. My name is James Hyung Kim, a senior researcher working for Hyundai Electric. Next slide, please. And these are the things that I want to talk about: our company introduction and what the ESS is and what Hyundai Electric has done so far and what kind of competitiveness we have. Next slide, please. So we, Hyundai Electric, belongs to Hyundai Heavy Industry Group, and we starting our business with shipbuilding, and now absolutely the best shipbuilding company in the world. And now we have so many types of business here, and we, Hyundai Electric, belongs to energy sector. And you may heard about our brother company, Hyundai Motors and Kia Motors, which is the world top 5 automobile company. So we, Hyundai Group, is really huge actually. And let's talk about our company later. Next slide, please. So we, Hyundai Electric, start our business around 40 years ago. And traditionally, we are power system equipment manufacturer, like transformer, GIS, or motor, switchgear, etc. But in recent years, we start our new business, energy solutions. And what kind of energy solutions we have, you can see at the bottom on the right side, like different types of EMS system solution. EMS stands for Energy Management System. So this system for factory FAMs, building for BAMs, ship for SAMs. And also we have asset management system, microgrid solution, smart farm, extra. And for these energy solutions, ESS and renewable energy sources are really important. And I'm gonna talk about these two components in this main presentation. Next slide, please. So before I start my main presentation, I would like to point out 3 important keywords in this title. This is the title of my presentation, which is given by the host. And I think this is quite good title. And there are three important keywords. First, distributed energy system. And I drew some diagram at the bottom on the left to understand what distributed energy system is. So compared to decentralized system, decentralized or distributed energy system sounds like a bit apart from the main grid, and it operates it by itself. It means they have to have their own operating system, and we call this EMS. So we don't have this word in this title, but I want to emphasize this component here together. Second, renewable. Yeah, without no doubt, we need renewables. We need clean energy. However, as a power system engineer, renewable energy sources are kind of tricky and difficult sources because they are unpredictable and they are uncontrollable. However, that's why with the renewable energy sources, supported system is quite required. And I believe ESS, energy storage system, is one of the perfect solution for that. However, one problem we have with this ESS system is quite expensive. That's why I think government or bank or the utility need to support financially for this solution. Next slide, please. And this is the concept what ESS is. And ESS, the system, can capture energy produced at one time for use at a later time. And I brought some structure scheme on the left side. And ESS is not a device. This is the system consists of three important components, which is, of course, we need battery. Battery is the component that the amount of energy can store. And we also need important component PCS, power converting system. These systems like water tap at the water system, they can control how much of power they can store or discharge. Or also we need EMS system because they need to monitor all those components and status. And sometimes they are getting some data from not only inside of the system, but also the outside, like weather or price of the electricity price, or sometimes grid status. So these three important components can make the ESS, and I marked in gray. And there are so many major functions we have with this ESS on the right side. We can so we can cut the peak demand, or we can get some money with arbitrage, or we can use this for emergency generator. And fourth function, this is quite important. ESS can use for stabilizing of the renewable energy sources. Next slide, please. Yeah, I'm gonna skip this, please. Next slide, please. This is the simplification of Korean ESS policy we have. And in brief, if we use ESS for smoothing renewable energy sources, we can get more RECs. Or if we use ESS for in this industrial sector, like a factory, and use for peak demand or shifting energy from peak zone to off-peak zone, we can get some incentive for reducing electricity bill. This is the really strong policy for this solution, and that's why we have so many projects in Korea so far. Next slide, please. And this is the solution, what Hyundai has done so far in Korea. We did more than 100 site project in Korea. We built more than 1 gigawatt hour of ESS installed in Korea. This is quite huge. It's quite remarkable. And one thing I really want to point out is we don't have any fire accident so far. I think this is really amazing, and we are really proud of this. And you can see some pictures on this slide with a lot of different texts. So different kind of energy solution we provide. And there are some record we have, I marked in red. We have 3 world largest ESS in the world. I will talk about it later in this presentation. Next slide, please. This building for ESS solution, we built 2 storage building for a factory industrial ESS. We built 50 megawatt hour battery for this project, and we used $23 million for it. Some people cannot imagine how 50 megawatt hour big it is. So here's the thing. More than 200 Korean average household can use this energy a month. So this energy can be stored at this system at once. This is quite huge. So this is the first large ESS solution we provide 4 years ago. Next slide, please. And next year after that project, we made 150 megawatt hour ESS solution for Korea Zinc. This is the name of the company. And absolutely, this is the largest industrial ESS in the world. And we break the record the Tesla has at the time. Next slide, please. And this is the function what this ESS work for. The first, we can reduce electricity bill with this ESS. And also we can participate in demand response with this. And also we can use this ESS for backup generator. So because of that government incentive, this project can pay back within 3 or 4 years. This is quite amazing, I think. Next slide, please. And this is the project with renewables and ESS. And we did this last year. And this is the really huge project we have. So you can see on the top, this picture, the solar farm was around 100 megawatt. And this is really huge. It's more than 200 soccer field size. And we Hyundai Electric participated in this project, and we did ESS solution, and we built 300 megawatt hour ESS for that. We used $83 million for only ESS, and this is the huge and world largest renewable energy sources project so far. And if the system getting bigger and bigger, management and controlling is getting really harder and harder, but we did really well and we don't have any problem so far. Next slide, please. And this is another project we did in Jeju Island, which is the southeast part of Korea. And we built the first PV plus ESS plus EV charging station in Korea so that the EV can charge from the clean energy. And we still cooperate with the Jeju Island. So at this moment, we are finalizing another proposal for that. The next slide, please. You don't have enough time, so I'm gonna skip some project. So this is a Thailand project, so one of the largest Thailand project, and we support diesel generator to reduce the energy cost and reliable system. And next slide, please. And you may interested in this project, microgrid, already 7 years ago we did. Guk Island is the really small island in Korea, and this is private island. They already had PV and lead acid ESS, and diesel generator, but they don't have know how to operate it optimally. So we put lithium-ion battery in this island, and we support EMS system so that they can reduce a lot of fuel cost, and they can make their island clean and noise-free. Next slide. And 3 years later, after that project, we also consult a Canadian utility company for microgrid. So they find the optimal capacity of the energy sources, and also they found the optimal operation strategy. And we also provide power system analysis together. And this is quite the great project we had. Next slide, please. So for distributed energy system, EMS is really important. I already mentioned it before, and we use this EMS system for building 6 years ago at the one of the luxurious hotel in Korea. And next slide, please. And next slide, please. And we expand this EMS system to factory. So we monitor more than 4,100 points, and then they can reduce energy costs more than 10%. This is quite huge because they use energy a lot. And with this system, we get the highest rate of FEMS certificated by the government. Next slide, please. And we also, after that, expanded that system to AI-CBM-based subscribable FEMS solution. This is amazing, I think. AI-CBM stands for AI and IoT, cloud, big data, and mobile. So we use all those high-tech solutions with these FEMS. And also this is subscribable. It means factory doesn't have to have their own system by their side. They can just join our system and log in, and they can use the FEMS. And this is the solution we provide at this moment. Next slide, please. And these are the things that what competitiveness we have, and we don't have enough time, so I'm really briefly introducing you. The first one, of course, data and connectivities. So we have so many experience with monitoring, gathering data, and analysis, forecast, and optimization and control. This is all those things we did by ourselves. Next slide, please. And we are also total solution provider. It means we make the business model by ourselves, and from the business model, we make business model to commissioning. So we did everything like a proposal, financing, civil, architecture, electrical things, fire protection, everything. And that's why I think we made a really reliable system. Next slide, please. And we are really good at the front engineering, like analysis, and I'm gonna skip this. So next slide, please. So this is the last competitiveness we have is AMS. So as I mentioned before, we are the device manufacturer, so we know how to manage the asset. So next slide, please. So we use this experience. We are using machine learning and deep learning for ESS asset management system. So if we have any kind of problem with ESS, we are automatically alarmed from the system. This is what competitiveness we have. And this is the last slide of my presentation. Thank you for listening.
Thank you very much. I am just, I'm sad that, I'm amazed you could pack everything in 15 minutes. But there was a lot of information in there, and it's very impressive. I mean, you've presented World Fair first that Korea did. You've presented a mix of renewable with non-renewable, EES system, microgrids, and a very impressive safety record. I'm sure our colleagues would have more questions about it, and also there was also mention of financial sustainability. So I'm sure many of our colleagues could be interested in knowing more after in the QA session. So I'm going to be moving to Stefan Young. And Stefan Young is from NeuReflect, and he will be talking about advanced metering and smart metering system management. So I will leave you with Stefan to speak about metering, and then we will go after that to our third presentation. So Stefan, please start. Thank you.
Hi, thank you.
Just before, sorry, just little housekeeping. I think somebody is unmuted and speaking, so I'm not sure whether they could make sure that they're muted.
Okay. Hi. This is Stefan Young with NeuReflect, and this presentation I'm going to briefly go through the AMI system. The advanced metering infrastructure, sometimes it's called the smart metering, but actually it is almost the same one. Next slide, please. In this presentation, we will discuss all these items. And next, please. Okay, let me start from the definition. Looking at the definition, there are different definitions from different countries. The first one comes from the state of Victoria, Australia. It was defined in the early 26 or 27. This definition focuses on it is the infrastructure, not a solution. And it is focused on the electric metering and the communication. The second one that comes from the United Kingdom, even though the advanced metering management at that time, this word was used, but now the AMI is common terminology. This definition focuses on the two-way communication and also the electricity and also the gas. Because in the AMR area, the communication was usually the one way from the server to the meter. But the two-way communication means that the communication from the meter to the server head and software, that is the push method, and the other one from the server to the meter, kind of the pull method. And in case of the UK, they also emphasize on the electricity and the gas, because there are several multi-utility vendors, multi-utility service providers, such as British Gas. They all provide electricity and gas. Next. Oh, the third one comes from the USA. It simply says the all pool system. The AMI system must be the pool system from the meter to the software. Okay, it does not explicitly define which one is required for the AMI. The last one comes from the state of Ontario, Canada. Here the components are specified: the meter, AMCD, LAN, AMRRC, MCC, WAN, and some related hardware, software, and connectivity. The last one, it emphasizes is AMI does not include the metering data management system, MDMS, which consists of the MDM, metering data management, and MDR, metering data repository. Next. This picture shows the configuration of the AMI system. In this picture, the scope of AMI is included in the red dot box. You can see there are meters with the communication module and regional collector, so-called the data concentrator, the access point, or the gateway. And the last one, the node. And then the control computer, actually it consists of the software called the head-end system and the hardware. And in this AMI network, there are two networks, the communication network there, LAN and WAN. Next. We already saw the main component: meters, communication network, and the head-end system. The top meter, the single meter with the is directly communicated with the head-end software through the network. It is so-called the point-to-point communication using the digital cellular over the fiber optical network. The second one shows the daisy chain meter together with the concentrator. All the meters are connected using the RS-485, and the last meter is connected to the data concentrator. Data concentrator, they communicate with the head-end system through the public network or the private network. The third one is based on the bus topology. All the meters and the data concentrators are located on the same bus. So every meter can communicate directly communicate with the data concentrator, or it can go through another meter by the repeating function. This is most common method for the electricity metering, especially using the power line communication, PLC. The last one shows the RF network. Next. So when it comes to the communication and the equipment, there are different standards being used. When it comes to the meter, there are usually two different standards, IEC and ANSI. In the North America, Central America, and the South America, mainly the ANSI standard is widely used. And for the other part, the IEC standard is dominated. When it comes to the communication type, there are wired and wireless. We already saw the different type of method in the previous slide. When it comes to the wired, the RS-485, that's just the multi-drop, and the M-bus, metering bus, and the power line communication is the representative communication method. When it comes to the wireless RF and the RF mesh, or the digital server is widely being used. When doing the communication, there are different type of the protocol also for the IEC and ANSI. When it comes to the IEC 62056, the so-called DMA concept is being widely used for the metering protocol. But when it comes to the ANSI, there is C12 series is being used. C12 consists of the C12, 18, 19, 21, and 22. It is commonly called the PSM protocol. For the backward communication, we use also there are the wired and wireless, but when it comes to the wired, fiber optical network is commonly used. It can be the private one or the public one. When it comes to the wireless, the digital cellular network provided by the mobile network operator is the most widely used. Next, just a moment. And when the data is collected by the head-end system, and then the data will be forwarded exchanged between the backend systems such as the MDMS or the OMS, outage management system, or DAS, distributed automated system. In this exchange, the so-called the CIM, common interface model is being widely used. But in the United States, another one almost the same. The multi-speak has been used for a long time. Next. So for the meter, there must be the communication module. So when because of the design of the meter itself, the way to integrate the communication module is somewhat different. When it comes to the IS meter, it is very easy to install communication module even after the installation of the meter, because there is no need to remove the meter from the power network. So you just open the communication compartment and put the communication module there. So it is easy to replace the communication module. For example, one day you use the power line communication, and then you replace it with the RF mesh network. When it comes to the ANSI meter, as you can see in the picture, it is much difficult to install the communication module after the meter installation. You have to open the cover, and sometimes you have to disassemble some component of the meter. So in order to do that, you have to remove the meter from the power grid network. So it's very difficult to replace the communication module. Today, there are now different words for the communication module, such as the NIC, network interface card, and the MIU, meter interface unit, is being used. NIC, actually, the network interface card, actually, this one comes from the computer. When the old times we use the NIC, you have to install the network interface card in your computer to connect it to the network. Next. Just let me check what the difference between the RF and RF mesh. in this picture, you can see the two different type of the circle. One is the single circle. Just let me call this node. The second one is the the double circle with the white circle in the inside. Just let me call this coordinator. In case of RF, this is actually the point to point. So one node should directly communicate with the coordinator. It cannot go to the coordinator through the another node. So if the path between the one node and the coordinate is broken, then actually there is no way to recover that one. But when it comes to the RF mesh, as you can see in the picture, the node can communicate with the coordinator directly, or it may go through the another node, because all the nodes in this RF mesh usually support the routing or repeating function. So if one node cannot communicate directly with the coordinator, it can go through another node. Even more, it cannot go to the other node, then it can select the another node to reach the coordinator. So in this RF mesh, self-healing, self-configuration is being supported. Next. Okay, let's look at the key functions of the AMI system. The bottommost layer is fully based on the functionality of the meter. We can see there's the tampering detection and the outage monitoring and power quality. And the next layer consists of mainly consists of the supply of the energy. We can see you can disconnect the supply to the energy to the customer or reconnect. And you can control the load. It is the individual load control. So even though even the energy supply is being supplied to the customer, but some individual load can be controlled by the meter itself. Load limiting is to limit the consumption by the customer. If we just define the limit to 2 ampere, 1 ampere, or 2 kilowatt, 1 kilowatt, if the customer use more than the limit, their meter automatically disconnect. Actually, they stop the supply to the customer, and after some time, such as 1 or 2 minutes or 35 minutes, the meter automatically reconnect and resume the supply of the energy to customer. The last one is the prepayment. So using this kind of the information functionality, when using the prepayment functionality of the meter, the customer must purchase the credit from the energy credit from the supplier, and the meter automatically deduct the credit depending on the consumption of the customer. And when there is no credit left, then the supply is disconnected. The third layer consists of the remote firmware upgrade and the time synchronization. Time synchronization is very important when it comes to the TOU, time of use tariff system. The top layer is the security of the data itself and the security of the communication. The last one is the home area network interface to provide the energy information to the customer so that the customer can participate in energy conservation. Next. The view for the AMI is somewhat different for the utility and the customer. For the utility, the first view is to protect their revenue. And the second one is to optimize their investment by the load balancing. And the third one is custom certification. As a customer, I'd like to pay as much as I use. And I would like to, if there is any power outage, I want the utility solve the outage event as soon as possible. And I need good power quality to protect my home appliances. Next. Okay, smart metering AMI is a part of the smart grid, and smart grid is a part of the smart city. And in the smart AMI network, just adding the sensors and actuators of the one part of the smart city can be implemented. So you can reuse, or we can use the AMI network for the smart city also. Next. Okay, here's the AMI project funded by ADB. The first 4 projects is the AMI, for the AMI. The last one is for not the AMI, but it is for smart prepayment metering system. this is one of the stepping stone to move to the AMI. So I just added. If somebody knows how their project is going, just let me know. Next. Okay, and we will go there next. Okay, this is the blue moon, our Earth. So we have to think green and do green to live in green. So we have to participate in the energy conservation, and the AMI can be a part of the solution to help this goal. Thank you so much.
Oh, sorry. I'm having trouble getting the video started again. Thank you, Stefan. I think it was just so technical in ways that my computer was feeling intimidated. So thank you very much for a very informative presentation. I've learned a lot of things. So it was kind of like an advanced metering infrastructure 101. Very interested in terms of the prepayment and how customers kind of, I think we find that customers want to pay, but they want to control their payments. So I think, you know, the smart metering and also the prepayment are very good solutions for developing countries. Well, I mean, everybody wants to control what they consume. So that's very, very interesting. And also how you tie it in with smart cities at the very end and to sort of explore those relationships a little bit more. And you know, the overall planet in terms of reducing our energy consumption. So you tied it up very well at the end. I'm sure my colleagues will have a lot of questions. I'm sure our energy experts were there geeking out and really, really enjoying all your diagrams. So yeah, and I think this would be a transition to Mr. Park from 0N, who will be talking about building energy management system, which I believe would bring everything that has been mentioned so far all together. And then we will transition to the Q&A session, and I'm sure there will be many questions for all of you. Well, I think first Ms. Kim, and then we will transition to the to the Q&A session. Mr. Park, go ahead.
Yes, hello everyone. This is Chuman Park. I'm a CEO of 0N company. I'm very glad to see you all here. Okay. The title of my presentation is Korean BEMS, the Building Energy Management System, toward a net zero building, industry, and city, global society. Next, please. Main contents are the global current status and Korean policy and BEMS and future plan. Next, please. First of all, I want to talk about UN Climate Crisis Convention, the reason why we need a net zero society. IPCC reported the global the average temperature increased 3.7 Celsius until 2100. That means sea level rise 63 centimeters, and there is a global ecosystem collapse. To preserve this global ecosystem, it's necessary to suppress the temperature rise to less than 1.5 Celsius to net zero. Next, please. This slide shows what net zero is. The UN recommended net zero as a means of stabilization policy. UN 197 countries effort to protect the global system from climate crisis. 121 countries declared net zero society. The right slide, the slide on the right, this figure show the definition of net zero, such as there are so many different type of the net zero is defined, that are defined, such as nearly zero, weighted zero, zero net, and zero carbon. ISO is defining various level of net zero. That's great. This slide shows global net zero conference starting to 2016 to world largest natural corporation focusing building. The reason is the building is more effective than other sectors. The main points are the 53 countries participation and 1,500 attendees per year, and partners, US GBC, ILFI, there are around the 50 organizations. I want to talk about the ILFI. It's a first third-party organization for zero energy certification around the world. Next, please. This picture shows the global greenhouse gas emission by sector. Energy accounts for 73% of global greenhouse gas emission. That means energy is very important for greenhouse gas reduction. Yes, please. This is the life cycle of building, design, construction, operation, discard, or remodeling. I will focus the operation. In this part, around 80% in charge of this life cycle. So that means we need transparent and consistent guidance for zero net energy, energy management implementation in operation. Next, please. Net zero energy international standards is developing in ISO TC 301. I am a convener of this working group. US and South Korea are leading this standard toward net zero. The title is Energy Management and Energy Saving in Operation. The scopes are organization and building. Interesting. We also in charge of industry too. There is a renewable facility process. That's great. This is infographic of zero net energy. The leftmost bar graph to show the energy consumption of general organization. In the middle blue bar, there is a dotted line in blue and red. This box show the energy saving by design, also by operation. The green bar indicated the renewable energy production, so which can be replaced with the energy consumption left for zero energy. So this explains what is zero net energy. That's great. Korean policy and ban. This is a timeline of the Korean policy to post zero net, zero energy building, especially in building, established in the regulation 2016. In 2017, zero energy building certification system came out, and from 2020, we have a mandate scheme in the public building. Next please. This is the based on the National Framework Act on Low Carbon Green Growth. We have a new, existing, and conduct. I divide this kind of some standard and regulation. We have a certification in green building and building energy efficiency rating and the smart building. Next please. This slide shows the certification of zero energy building. We have 3 criteria. That is, first, the building energy rate, the efficiency rate. The second is energy independence rate. Third, the BEMS, building energy management system. There are 7 different types of incentives, such as the relief, the pro area review, also housing and urban fund loan. Next please. This figure shows the building energy management system guideline. This guideline content the renewable sensor monitoring, optimal control analysis software. That's great. This table shows point for each BEMS item. There are 2 tracks. One is installation confirmation. Another track is the extension of the BEMS certified BEMS. To be certified, at least organization did 60 points. Next please. This is an example of BEMS. I want to show you the major function of BEMS. Renewable production, energy consumption, energy independence rate for zero energy, and energy use, energy hour, and energy savings. Next please. This shows the world first BEMS standard. So our government developed BEMS standard, part 1, part 2. The function and data, the processing result are defined in part 1. In part 2, the selection of control point and data management and energy saving calculation are defined. That's great. This is an incentive of another, not BEMS, it's EMS. There are 2 major things. One is exemption of the energy audit. Another is a tax credit for investment. For large company, 3%, the medium-sized company, 5%, and small-sized company, it's a 10% tax reduction. Next please. This is show there are around 1,064 buildings certified so far in South Korea for zero energy building. I want to focus, it's a zero energy city, the project in South Korea. Next please. It's a BEMS-related green building certification. Due to limited time, I will skip. There are so many the certification on green building. Next please. It's a future plan. So we have Zero Energy Building Alliance. This alliance purpose are innovative zero energy industry corporation and commercialization of zero energy technology and finance and policy solution. That's pretty. This is the left slide of my presentation. This is show 2050 net zero future. This figure I extracted from our ministry the document. There are 10-point technology. We are focusing this kind of technology, such as solar, wind, and building efficiency. Thank you. That's all.
Thank you very much. And thank you very much for being cognizant of time. In fact, we owe you 2 minutes and 9 seconds. So thank you very much. I think this presentation was a great ending and sort of kind of tied up everything, because we did small components like the EES, and we did also components of metering, which are all components of net zero in general. But I think most importantly, like I think you said 73% of GHG comes from energy, and that was really stark for me. There's also, I think, a really great alignment with the policy framework, but most of all, I think what's most interesting, you also tied it up with incentives and what governments need to do to incentivize net zero. So this is extremely interesting. I mean, especially right now when we're looking at what is happening in the world in terms of climate change, in terms of the heat waves right now in North America and parts of the Middle East. I absolutely think that this is a very timely presentation, and with the priors alignment, I think this is the way we're going to be thinking more of this in the future. So, and I think it's a little bit too late, but I'm kind of very happy that there are companies and approaches like the ones you have presented right now that we can adopt readily. So now I am going to go to our next presenter from Jeju province, and she is Ms. Mi-Young Kim, and she's Assistant Director of Low Carbon Policy Division. So I would like her to start right now if possible, and thank you very much. This is a bit weird because we started with the context, we ended with the context setting, but it's all good. So please go ahead. Thank you very much.
Hello, I am Mi-Young Kim, Director of Low Carbon Policy at the Special Self-Governing Province. It is very meaningful for me to participate in the Korea ADB Urban Development Forum and share this case of operating electric vehicles and charging stations using renewable energy. Next. Jeju, which legacy clean nature as its most precious asset, set a challenging goal of carbon-free island in 2030, 10 years ago, to respond to the climate crisis and achieve sustainable growth. Jeju CFI 2030 policy is a new model that encompasses energy, transportation, power system, and big data. Representing Korea, Jeju shared our efforts at the COP21 in Paris, which drew attention from around the world as a model that could be applied to more than 2,400 cities. Jeju leading case were also shared at various international events such as the Davos Forum and Boao Forum. Next. Jeju is Korea's top tourist destination with more than 50 million tourists annually. It is also an environmental treasure island, being the only region in the world to be awarded a Triple Crown from UNESCO. It also has a geographical advantage of being only a 2-hour flight distance away from 60 cities with a population of over 1 million. In addition, it is possible to travel around the island on a single charge of an EV, thanks to be abundant to renewable, such as wind and solar energy. Jeju also has a sustainable environment and infrastructure to develop the low-carbon green industry. Next. There are two important goals to become carbon-free by 2030. The first is to supply 100% of electricity demand on the island using renewables such as wind and solar power. The second is to replace 100% of transportation with eco-friendly mobility such as EVs. Next. To achieve the CFI 2030 goal, we set a target to reduce greenhouse gas from about 4.2 million tons to about 2.8 million tons and focused on three values: cleanliness, sustainable, and growth. Our four main policy goals are as follows. 1. Meet 100% of electricity demand on the island with renewable energy. 2. Replace 377,000 registered vehicles with eco-friendly EVs. 3. Reduce energy demand by 23.24%. And 4. Foster new energy industry. Next. Led by the public sector, Jeju Island is expanding offshore wind power generation. This year, Jeju is carrying out a demonstration project of an 8 megawatt floating offshore wind power plant, which is the first in Korea. Last year, renewable energy generation rate in Jeju was 16.22%, which means we have already met 80% of the government's 2030 target. Energy independence is also gradually increasing as the supply of new and renewable energy increases. Next. There are already over 23,000 electric vehicles running in Jeju. We are planning to stop registration of new internal combustion engine vehicles from 2030. We are also operating an EV battery industrialization center, which is another first in Korea. The center will be used to recycle waste batteries from EVs as energy storage systems. Next. In 2015, we announced a midterm to long-term comprehensive plan for expanding EV supply and nurturing the industry. Since then, a step-by-step plan is being implemented. The first stage was to develop an ecosystem sustainable for the EV industry by 2017. The second stage was to build a global EV platform by 2020. The third stage is to establish a self-sustaining EV industrial ecosystem by 2030. It is expected that 100% of vehicles in operation will be converted to eco-friendly vehicles by 2030. Next. This is the current number of registered electric vehicles in Jeju. About 22,000 out of about 394,000 registered vehicles are EVs, accounting for 5.5%. The figure is the highest in the country. By vehicle type, a majority is for private use, then followed by rental cars, taxi, and government fleet. Next. This is the current status of EV charging infrastructure. There are about 18,000 electric vehicle chargers, about 4,400 open, and 13,500 personal. Slow chargers account for 90%, and fast charger 10% of the total. By one time, 75% is for individual use, 70% for private business, and 7% for government offices. Nationwide, the number of charging stations is 50 chargers per 100 EVs. In Jeju, there are 97 chargers per 100 EVs, meaning Jeju has the best charging infrastructure in the country. Next. This is the current status of various EV chargers in Jeju. Personal home chargers taking up the majority, and many installed and used the house, office, and rental car companies. Open charging stations are installed at government offices, public parking lot, and tourist sites to enhance user convenience when charging vehicles. In addition, we annually supply customized chargers for vulnerable road users, such as people with disabilities as well as electric bus. We also distribute P-charging socket-type chargers for apartment buildings. Next, in order to further increase the supply of EVs, charging infrastructure needs to be established first. Accordingly, Jeju grants subsidy for charging stations. Subsidies are set differently depending on the charger type. First, the Ministry of Trade, Industry and Energy provides freight charging business with $16,400 from the Asian government and $6,400 from Jeju government versus for one 50 kilowatt charger. Post-law charges, the Ministry of Environment subsidize $1,820 for charger one using the Asian budget, but provincial subsidies have been discounted from 2020. Next, we are also actively promoting policies to enhance compensation for EV drivers. In April 2015, the Jeju EV call center opened for the first time in Korea, and it's currently operating 24 hours a day. The center provides information on EV and charger properties, charging guidelines, customer service, as well as emergency assistance. In addition, we also distribute the Happy Charging Map for EV drivers to advertise charging station locations, charging etiquette, and user manual. To effectively crack down on charging disruption, we developed an automatic monitoring device feature installed at 35 charging stations. By recruiting EV supporters, we monitor charging stations in the province, promote the policies through social media, and share opinion on EV experience so that we can reflect them in future policies. Next, this is an EV charging station in Jeju using renewable energy. To expand charging infrastructure, we have been constructing renewable energy-based charging station from 2019, and the project will continue until 2022. Through this system, electricity generating using solar power is used to charge EVs, and the remaining power to sold to the power grid. Currently in Jeju, there are 2 stations in operation. Next, the following is an example of a smart grid V2G charger. This pilot project sends remaining electricity from EVs to power grids, which are then used by buildings. Currently, a V2G charger is installed in 22 government vehicles for the pilot project. The result of the project will be analyzed and used to expand the project to public installation and rental cars in the future. We aim to establish a next generation smart grid that enhance the safety and the interaction of the power grid. Next, one of the ongoing project is a special regulation free zone for EV charging service, which aims to address charging difficulties and foster related industries. Jeju was designed as a special zone by the central government in 2019 and is currently implementing 4 projects. The first demonstration project aims to reduce charging time and installation costs by adding a 50 kilowatt battery to an existing charger. Second is a demonstration of a mobile charging station and to minimize occupying the space in the parking lot. Third is a demonstration of a shared charging platform to increase use of chargers when they are not in use. The last project is the demonstration of a mobile EV diagnostic service that exempts EV batteries and eventually can contribute to vitalizing the EV second-hand market. Next. This is the EV Battery Industrialization Center. As the number of EVs increased, waste batteries became a concern. So we are establishing a system to manage the life cycle of EV batteries from collection after scrapping to reuse. The center opened in June 2019 to establish a system for collecting waste batteries and evaluating residual value. We are currently testing the use of waste batteries in public street lamp and ESS products. In addition, we plan to establish a safety certification system for mobile products such as wheelchair batteries and provide support to port tests in the private sector. Next. Another project we are working on is the production of clean green hydrogen. Green hydrogen can be produced as electricity of water using electricity product from renewable energy. A demonstration project is ongoing to produce, store, and utilize green hydrogen. We plan to use it in various fields such as hydrogen fuel cells, hydrogen cars, and hydrogen drones. Next. Over the past decade, Jeju has accumulated a lot of experience and established the infrastructure through the implementation of the Carbon-Free Island 2030 project. Jeju aims to become a global green new frontier based on a new model that combines renewable energy and eco-friendly mobility. Thank you for your attention.
Thank you so much for a very, very interesting, we pause this, yeah, for a very interesting presentation. And I'm just wowed by how ambitious the plan Jeju Island has in terms of renewable energy and the ambitious mission they have for 2030. So it's just, quite frankly, it's extremely ambitious, I believe. And I really like the 5 examples that you took us through, from renewable charging stations, all sorts of EV solutions for vehicles, to the sort of green hydrogen productions. I think there's a lot of firsts there. There's a lot of sort of scaling up opportunities over there. And I think many of our colleagues would be interested in learning more about this. And now we have about 21 minutes for questions. So I'm just going to open the floor. Colleagues, if you want to put your hand up, raise your hand and ask the question yourselves, or maybe put it in the chat box or the Q&A box. I would prefer the Q&A box because it would be easier to keep an eye on, but I'm just going to open the floor for questions. Anybody? They're a bit shy always at the beginning, but then the questions start to flow. Oh. All right. I mean, if there's no questions, I'll probably ask the $1 million question. And I'm going to ask this to all the panelists. You've presented a lot of solutions, and some of them are applicable to developing countries. But we're just wondering, and this has been a question that was recurrent through all the sessions, how do we apply these very advanced probably expensive solutions to developing country contexts. So can I probably start by Mr. Park and then move to the rest of the panelists?
Okay, you are asking about what is the best way to apply this kind of technology to developing country, right?
Yes.
Our country and my company also are trying to find the better solution that is for very not expensive. It's cheap and applicable any kind of building and industry. So the point is the cost of the hardware and software and how to optimize this kind of energy use. So this kind of technology is developing as time goes by. So there are so many nice solutions in the world. So that will be applicable. That means I'm talking about some kind of hardware. For example, the metering, it's more reliable. Comparing with the previous the sensor. So this kind of technology will be very helpful, and combination of this kind of combination of technology will be applicable to developing country. That's what I'm talking.
Okay, thanks a lot.
Mm-hmm.
I'm probably going to do like a follow-up, but kind of within this question, and I'll probably ask Stefan to answer it. Stefan, I think Mr. Park just said that the unit price is going down, and that's very important. And when those prices go down, you can sort of integrate different solutions and give a very affordable solution to a developing country. I wonder whether this is the only hindrance, and what do you tell governments when you want to convince them or clients in developing countries? Obviously, you showed us a list of where you've taken this technology of yours. How do you convince them? What do you tell them? Is it only numbers, or how do you calculate that feasibility to show them that this on the long run would be more beneficial to them than short-term, non-renewable, non-green solutions?
Yeah, actually, yeah. In fact, there is the economy of the mass there, but in the underdeveloped countries, do not stick to the single solution. For example, in the smart prepaid metering project in the Bangladesh, even there is the ICT is included in the project, and 1 million meters are installed in the field. But among the 1 million, only the 100,000 units meters are with the communication module. So just like this one, but no, but the remaining 900,000 meters have the possibility to communicate with the backend system. In the future, just by adding the communication module there, then and the increasing the bandwidth for the communication between the mobile network operator and the data center of the BREV, all the 1 million meters can be incorporated. In order to do that, one of the most important thing is the standardization of the component and the communication protocol, something like that. So just taking one single solution, such as the RF method, the PLC method, and the digital cellular, is not a good solution for the underdeveloped countries, because it depends on not only the utilities environment, but also depends on the public network, such as the mobile network operator. So in order to make it feasible in the future also, and now to make it easy to start, then we have to make the more feasible solution, but it must be based on the standard. So the utility, the employer must be able to make the standard for their own pictures. Then in the future, you just purchase more the units such as meters, and together with the communication module, or the only the communication module for the existing network to the meters. This is the way I just want to recommend, and actually this is the way how the project in the Bangladesh for the smart prepaid metering was implemented.
Right. So tailoring your standard and then kind of tailoring the solution and mixing them in order to create a feasible solution.
Yes.
Okay. All right. So perhaps if Hyun can sort of tell us a little bit about feasibility. Hyun Kim. Sorry, I might be saying your name wrong, so I apologize.
All
I'm
right.
just reading it out like it's written. So
Just call me James.
James, okay. I'm
And
sorry. Yeah.
What is the question again, please?
The question is that how do we make these solutions feasible for our developing countries?
Through the solution we have done so far, I think the microgrid solution could be a good solution for developing company, because I think there are so many isolated grid, like island or some isolated town from the main grid. And so they have to get some power from somewhere. So if they have the main grid around there, I think that's easy. But if they don't, microgrid solution with the renewable could be very good solution for that. But the problem is, I think the price, the cost, because renewable or the ESS system is quite expensive for building that. So I think the best way to achieve this project is, I think, how to convince this project to the government or utilities. So I think the best way to convince them is just to show them, to calculate how much money we can save through the microgrid compared to the building the strong main grid. I think this is the simplest but the strongest the way to convince them. And this is my opinion, I think.
Okay, thank you very much. I will move to Ms. Kim afterwards. I think we have one question from Akju. Akju, could you say the question, because it's kind of long and I'm going to be reading it, but perhaps you can talk it over if you can.
Yes, can you hear me?
Yes, we can.
Yes, so yes, my question is already in the chat box, but as you requested, I can repeat. Just I'm wondering, for example, for the case of Jeju Island, it's a very famous case, pilot case. But at the same time, I'm wondering who are the service providers for this initiative. As we could see. During this session, there are so many competent Korean companies and the Korean technology solution providers. But at the same time, I think there would be some advantages of working with non-Korean companies or non-Korean technologies. So, my question is specific to the Jeju case. So which kind of service providers are you working together? So, and what are maybe it's a bit complicated question, but what is the percentage of non-Korean or Korean technologies in building that wonderful initiative for Jeju Island? Is it good? Is it clear?
It is a clear question, but
I get it, your question, but
I'll answer the question.
Oh, right. Okay.
And actually, our presentation give you our many specific pilot examples. So we are just doing the demonstration of the many things, such as the renewable energy, just chargers and the greenhouse gases, and we are just demonstrating many advanced technology. So far, so we get cooperated with our domestic company, and we have some safety about the present demonstration pilot, and then we cooperate further outside the world. So we need some time to we convince some safety about the new technology, and then we will cooperate with the foreign company. That's all. Yeah.
Okay.
Thank you so much.
Okay, thank you, Akshu. Perhaps I have another follow-up question for Jeju Island. Say we're going to work in a developing country context and are an island or a city or whatever with a lot of problems. Where should they start? What is the most important thing they should start with if they want to follow your example? So,
네, 개도국에 적용을 제주의 기술이나 이런 사업들을 개도국에 적용을 할 때 어떤 부분부터 시작하면 좋을 것 같아요?
Okay. In developing country like Jeju City, we have to we make a policy like a subsidy. We supplying the EV is one of the main goal in Jeju. So we need some policy to subsidy policy. And then we need some infrastructure policy also. So we actually we have a lot of the chargers around the Jeju Island, and so we have installed a lot of the chargers in public sector first, and then we cooperate with the private company related to the chargers. So I mean, just we make some two part of the policy in supply of the EV and the installments of the infrastructure.
okay, thank you. I believe that a common thread that is kind of developing here is the importance of the policy structure. I mean, it's been incentives, policy structure, standards, and then we can start talking about different solutions. So I think this is a very good lesson for at least our ADB colleagues to think about projects holistically and include a strong policy component before going for these sort of energy solutions that can be advanced. But I think once we have the policy framework, it makes things perhaps easier to be working within that, because it's kind of a common understanding that the government also wants to go this way. So thank you very much. I'm wondering whether there are more questions from the attendees. Anybody? So there are no questions in the chat box. No hands, no raised hands. We have about 5 minutes, so if there are no more questions, I would probably just go back to the speakers and ask them whether they have anything that people should take home, like a closing remark that they want people to remember after the session. So can I start with perhaps James, Kim? Sorry to put you on the hot seat like that.
Just
But
let me
just
think
one
about
thing
it.
for people to take home. I mean, it could be a thought. I don't know.
I think I mentioned before when I give my presentation, new technology or new paradigm need lots of money for achieve that. But not only for developing company, but every company has a problem with to have a project with this new technology. So I think government or banker or the utility need to financially support all the project to make the better world. And this is the message I want to talk about this presentation and your question. Thank you.
Thank you. Thank you. Stefan, do you have any words of wisdom to close with?
Oh, yeah. You know that the technology is not the technology itself. Technology gives you some the useful way and the methods, measures to improve our life. But that I mentioned in the last of my presentation, even though the technology can provide more the beneficial to us, but if we do not do the right things, the technology is not more the technology. So everyone must think green and do green to live in green for the time being, for ourselves and for our children, and also for our descendants. So we have to think in green and do something for the green to live in green. That's my last words. Thank you.
Very nice. Thank you very much. Now, Mr. Park, do you have a final conclusion?
How can I call you? Lara?
Lara, yes.
Yeah, Lara. Do you think what is most important things in energy?
What do I think the most important thing in energy is? Oh, wow.
So why do you have this kind of question?
Because I just want people to leave this thinking that they are, oh, I see what you mean. I want people to leave this with things to think about when they're thinking about energy projects. Because like Stefan said, we can't really, our objective cannot be the technology for the sake of technology itself. So our objective is more a greener planet. And then we do have James who said, well, money is very important, but that's very important. So people have to put their money where their mouth is. You can't keep talking about policy, but not sort of fueling it with money. So I'm just wondering, when people are thinking of projects, like I thought Stefan's piece of advice, not to think of technology for the sake of technology, is very, very important. So, so if you were somebody thinking of changing the energy map or doing net zero in a country that has a lot of challenges, what would your first instinct be?
Yeah, the point of my question is how to quantify our energy savings in city in the world. That is the point. So that means, in my case, I experienced a lot of trial error to getting the data, because data can explain how I saved my energy in building an industry, in district, and in the world. That is the problem. That means actually we evaluate around 90% of data is useless. That means we have some error in installation of the hardware and analyzing some data. So I want to advise about your country, any developing country, keep in mind how to prepare the getting the data. That's the point.
Okay. All
Yeah.
right. All right.
It's my ritual.
All right. Thank you very
Okay,
much.
thank you.
So we're running over, but I just want one last word from Jeju Island, if possible. So just, any word of advice for people going on this energy efficiency journey.
I'm very honored to be here, but it's the first step to share our green policy. And actually, today I give you some Jeju policies. So usually Jeju governments make a policy to help infrastructures or some subsidies. But the important thing is how people in Jeju think about it. So we have to work together with people in Jeju. I mean, furthermore, we work together in the world. So we have to change our consciousness about the green, and society is very important these days. Thank you. Yeah.
Okay, thank you very much. So we spoke about society, we spoke about feasibility, we spoke about the technology and the policy and subsidies. So I think, yeah, it's a pretty sort of holistic view or perspective on energy management. And I thank all our speakers today and our attendees, and see you, well, whoever will be attending tomorrow. And thank you very much to everybody. Thank you.
Thank you.
Thank you so much.
Thank you so much.
Bye-bye.
Take care.
Bye.
Bye.